Before we get to the very end and finally get to quadratic equations, a couple of things first. I checked back on that video from a couple of videos earlier. The whole sequence I think was about 2 minutes. I think there were around 25 questions that I asked in those 2 minutes. That would be around 12 questions per minute or 6 seconds per question. Is that a realistic pace for a real classroom? Yeah, it is. That can be achieved with good choral response and good signalling. And this in an environment where everybody's used to that and they've worked that way before. So I think that's a good indication about the kind of pace you can get into a classroom. Over 20 questions in a couple of minutes, and yeah, just a good example of that. Also on etymology, I found that Etym Online is the best website for this. Google offers its own stuff, but I found this to be really helpful. Whenever I come across a maths word and I'm trying to figure out where's that come from, why is that the word we use, anything at all, things that we start to take for granted, like hypotenuse turns out means, tenuse means, or don't know if it's tenuse or tenuse, but it means tension. And so the hypotenuse or the hypotenuse, that's the part of a ship's sail. If you imagine a triangular ship's sail, that's the part that would normally be under tension. That's where the word comes from. Or my personal favourite, trigon translates directly into triangle in modern English, the same way that which curiously we've kept for most of the other shapes. We've kept that ending, like pentagon, hexagon, septagon, triagon. If only we had, then trigonometry would really obviously be triangle and then measurement for metry. So the etymologies are really helpful for these kinds of things. Moving on to the last thing I want to cover before quadratic equations, a couple of special cases that we really do need to deal with. So the first is the fact that x to the power 1 can be written as just x without the 1 there, so we've got a secret 1 now. This could have been taught previously, they may know it already. Whether they do or do not, we probably want to handle this at some point. We want them to be able to deal with x without the explicit 1 written up there, so they can look at something like this and know that the degree of that term is 4. The other one is this. This is important because it means that this is a polynomial, because it is also equal to that, or can be written that way. I mean, to talk about them as being equal, I think, falls into the trap. It's correct, but it falls into this trap of gives the answer, or whatever the answer is. Really, these are just different ways of expressing the exact same idea. They yield different information. They give a different amount of complexity on the paper in front of you. But I want it to be included just so it is clear that this is a monomial. This is called a constant polynomial, or a constant monomial in this case. And to communicate each of these, it would just be a transformation. You're literally, as with the sequences previously, we're just going into a few examples like maybe this, and saying rewrite that with a secret 1, and we're asking them to produce this. Or maybe, for the most part, keep it simpler, make the 1 secret, and we're asking for that. Or vice versa, we're giving them something like this and asking what is the exponent on the unknown, and we want 1 as the response. Either way, these are all transformations.